All right, gang, from a visual perspective, let's focus on what we just did. So right now in our implementation, we have leaf 101 connected to spine 201, and then we have leaf 102 with spine 202, and we know that we're dual connected, following the principles of a cloth leaf spine architecture. Now what I did is I went in and I created a loopback interface. That loopback interface was created on each one of these respective switches. We gave it an IP address of 183.1, and then it was the router number twice. 183.1.201. 201, and then over here 183.1.102, 102, and 183.1.202, 202. So those are the interfaces that we configured. We also went so far as to configure ospf. So down here I'm going to write ospf area 0. So every interface that gets a dot is running ospf area 0. So that means this interface is running ospf area 0. This interface is running ospf 0, as are all of the physical interfaces are all running ospf area 0. Now we're doing it in an IP unnumbered mechanism when it comes to those physical interfaces, but all of these interfaces are all running ospf. And what that does is it allows me to be able to configure my ospf enabled transport. Now the beautiful thing about ospf is ospf supports equal cost multipathing, and that's something that's going to be very, very important to us later on, because ultimately, remember, we still have those hosts that are sitting out here that I want to generate or I want to use to create traffic. Now, when we look at what's going on in the configuration, we have to really pay attention to the way resources work. Now, when it comes to VXLAN, so Virtual Local Area Extensible Network, so VXLANs, sorry, I drew a blank there. When it comes to the idea of a VXLAN, we have to pay attention to the way things work, because a VXLAN is responsible for encapsulating traffic. And VXLANs actually take classic Ethernet information, and what they do is they basically encapsulate it with an outer VXLAN header. They take constructs from the inner header, and then what they do is they just re-encapsulate it. So here it's coming in as a layer 2 frame. Here it leaves out as a VXLAN packet. And this process takes place using something called our VTEP, our VXLAN tunneling endpoint designator. Now, what we're going to do is in this lab, we are going to create some VTEPs. So we'll create a VTEP for switch 101, and we will create a VTEP for switch 102. Now that VTEP is actually going to be tied to another loopback interface. So what we're going to do is we are going to create a loopback interface, and what we're going to do is again leverage the functionality of IP unnumbered when it comes to creating a logical interface later on down the road. So the address that we're going to create is going to be 10.1.101, actually we'll do 100.101/32, and over here we'll do 10.1.100.102/32. So that gives me the loopback addresses that I'm going to be using. Now, it becomes important for us to also keep in mind that to function, these interfaces are also going to have to be advertised into ospf. Now, later on down the road, we're going to create a logical interface. We'll be creating something referred to or called an NVE interface. a network virtual edge interface. In fact, we'll create NVE1. And NVE1 will actually take its IP address from loopback 0. Over here we'll do the same thing. We'll create NVE1, and what we'll do is we'll use unnumbered to accomplish that. But we're not there yet. What we want to do right now is go ahead and get these set up, and then what we need to do is we need to address one of the behaviors of VXLAN, and that's going to be the way that VXLAN is going to function. Now, I said specifically at the beginning we were going to focus on flood and learn behavior for VXLAN configuration. Now, flood and learn implies we're going to need multicast. And we are going to use any source multicast, ASM, so I'll go ahead and say ASM multicast, and specifically we are going to use sparse mode. Now, sparse mode requires the identity of a rendezvous point, and I said specifically what we're going to do is we're going to create an anycast rendezvous point configuration. Later on we'll entertain other mechanisms. As an example, we'll look at, say for instance, a phantom RP in the context of bidirectional PIM. But right now we're focusing on protocol independent multicast sparse mode PIM for the configuration and the setup. And ultimately, remember, we're going to be looking at 224.0.0.13, which is going to be the multicast address that we're going to be using on a link-by-link basis in order to build what we are referring to, or will refer to, as our PIM neighbor adjacencies. So with this being said, what I want to do is I'm going to return our attention to the command line in the next video, where what we're going to do is we're going to complete this portion of our build, and then what we're going to do is we'll move on to a conversation about how we're going to implement this idea of our rendezvous point using an RP or an anycast RP set. So I'll see you guys in that video.